Up to this point, we've been content to simply say that the electrons in an atom or an ion are simply distributed about the nucleus in an electron cloud. Now we need to be a little more specific about where the electrons are located in an atom. The electrons are in regions of space called orbitals. These orbitals are in fact probability distributions that come from the solutions to some complicated math equations that involve quantum mechanics. Quantum mechanics is way beyond the scope of this course. I do, however, want you to know approximately what the shape of some of these orbitals is, and that the shapes themselves are determined by quantum mechanics. I'd like you to know that an s orbital has a shape that's approximated, or not approximately, but exactly a sphere. A two-dimensional approximation would be to simply draw a circle. A p orbital looks more like a hamburger bun. And a two-dimensional representation might look something like that. D orbitals actually look sort of like four balloons tied together. In sort of a cloverleaf arrangement. One thing that's important for you to realize is that this is one s orbital, and each orbital, no matter what it is, can accommodate only 2 electrons. So this one s orbital here, there's room for 2 electrons at most. This is one p orbital. It may look like 2 orbitals to you, but it's one p orbital. There are 2 lobes. Okay, it just happens there's 2 lobes. Still, there's only room for 2 electrons in this one p orbital. This d orbital, likewise, has room for just 2 electrons. It looks like there's 4 orbitals, but there's not. There's just 4 lobes to this one orbital. Room for only 2 electrons.